Welcome to the Machine Learning, Data Science, and Ethics in AI track session for this afternoon. And my name is Fatma Tarlıcı. I am one of the co-chairs of this track. And today, together with my colleague Ben, we will be helping facilitate this session for our speakers and for you guys. We have a great lineup of speakers this afternoon, and at the end of each talk, we will have about 5 minutes for you to ask questions. If you are in the room and would like to come up and use our microphone in here on this desk, you're welcome to do so. You can also post your questions in our dedicated Slack channel, which is called track dash and then the name of the track. So for virtual attendees, you will also be posting your questions on the Slack for our speakers. So with that, I would like to invite our first speaker today, and Niels Bantilan, and his talk is titled Pandera, Beyond Pandas Data Validation.
Okay, hi everyone. I'm super excited to be here. My name is Niels Bantilan, and I've been kind of doing this, I guess, every year or every time I get a chance to talk about Pandera. Who here has heard of it, or let's say who has used it? Okay, who has heard of it? Okay, who knows about Pydantic? Okay, so there's like some percentage there that, should increase over time, hopefully. Cool, so before I get started, just a little background on myself. I have a background in biology and dance. That was my undergrad, kind of like pivoted over to public health, which is when I started doing stats, which is then when I started doing data science, machine learning, all that good stuff. Currently, I am the chief ML engineer at Union AI. It's a essentially machine learning data infrastructure company, but that's neither here nor there for this talk. I'm also a maintainer of Flight, which is a orchestration tool for data and machine learning. And I'm the author of Pandera and Union ML. And as you can tell, I really like open source. I like making tools. I like figuring out what kind of the software design fits in people's head so they can be more productive. So this talk is not exactly about Pandera or data validation, although we will cover those two things. The main thing I kind of want you to take away from this talk is sort of like the process of software development, and in particular, open source development. This is just my personal journey through it, with my own little quirks and preferences. Every project has its own origin, but I wanted to take you through how I came about kind of writing Pandera and evolving it over time. So I'll break this talk up into 4 parts. The first part is, I should have increased the font size there. Okay, that's all right. I can't even do that. Cool, so first I'll talk about the origin story of Pandera, and then go into how it evolved as people started using it, started contributing to it. And then, I don't know if you can see the flamenco from the chicken egg to the chicken to the flamingo, the revolution of having to rewrite Pandera's internals, because the initial assumptions, and it really was a personal kind of toy project in the beginning, did not hold as it grew. So there was just a sort of breaking point where had to kind of do this very intense rewrite. So I'll talk about that and some of the lessons learned from that. And then I'll go finish up with what's next for the project, and how you could get involved if you're interested. So first of all, the slides can be found on these links. This link will be shared. I'll also post it up on the Slack, so you can check it out. So let's get started. Pandera started off as a little thing that I wrote asking the question of how can I add types to my data frames, because I use pandas a lot every day, and I would get bitten just by type errors and just things going wrong that if you've used pandas or any kind of mutable data structure, you might have found this kind of issue date times not being the right format, float columns that are supposedly float columns, but then you have a one random string in there, things like this. So this leads to the question of why I should validate data. And everyone obviously knows what a data frame is. It's a kind of a tabular data structure that's columnar and index aligned. And I like to think of data validation as the process of falsifying data against explicit assumptions for some downstream purpose. And I say falsify, and the key word there I guess I'm hearkening to the scientific method, where if I make a claim that all swans are white, to confirm that claim, I'd have to be very certain that all the swans I go out and find are white. Whereas I can easily falsify it by finding the first instance of a black swan, or a purple swan, or some other colored swan. So with that kind of premise in mind, data validation, more practically speaking, is needed because it can be difficult to reason about data, especially data frames, where if you're reading code, you can kind of infer what columns are in there and what types there are based on column accessing and what operations you use on them. But really, I want to be able to ensure that data quality is kept up as data progresses through some kind of data pipeline, be it an analysis or modeling or visualization pipeline. This is important for many, many use cases. I would argue for any project that uses data, but it's especially important if you're doing a scientific study or a business critical analysis or something like this where you're making decisions off of a visualization that could be completely wrong because there was something wrong with your data. So it's story time. Everyone has a personal relationship with their data and data frames. So I want to get into some fictionalized version of what I would experience very often. So you're maintaining a pipeline, and one day it conks out, and you see this error that you can't multiply a sequence by non-int of type float. Okay, so you go to the offending function, this process data function, and you look around and you see some hints of what might have happened. There's a df.assign call where I'm trying to multiply hours worked with wages per hour. So you insert a breakpoint just to see what's going on, and you run the thing. And you print some code out, or you print the data frame out, you look at the types, and you see in this hours worked column, which is an object type, there's a string in there, right? This thing I mentioned earlier. So what you do is you squash the bug, you effectively explicitly coerce the types into the expected floats, and then you go about your day. A few months later, you come back to this code, and you see someone else has updated it, and you see oh, there's this type annotation here for data frame. Looks like a generic with a raw data type being added into it. And the output of the function now is the same thing, but with a process data type attached to it. And all the type coercion stuff is gone, right? There's just the calculation of that you really care about, which is computing various columns deriving columns from other columns. So you look above the code and you see these types. These are effectively Pandera types. And we'll get into some of the syntax, but really the crux of this story is that the better you can reason about the contents of the data frame, the faster you can debug. The faster you can debug, the sooner you can focus on downstream tasks that you care about. And by validating data through explicit contracts, you can also create effectively data documentation in code. And you also get a very simple stateless data shift detector. So I set about writing Pandera with a couple of design principles in mind, and this was actually something I wrote up in 2020 when I first presented Pandera right here at SciPy. So the principles go something like this. Expressing validation rules should feel familiar to Pandas users. Data validation as an activity should be compatible with the different workflows and tools of a data practitioner. And I don't want to have to set up a lot of things or put a lot of boilerplate or configuration to get that started. I want to be able to define custom validation rules really easily. The validation interface itself should make debugging, finding the error, the one cell in that data frame, right? Make that really easy. And integration with existing code should be as seamless as possible. And all of this is just really to make, data validation is already a thankless job. You kind of want to move on very quickly. So lowering that barrier is something that I cared a lot about. Also because I use the tool, so I wanted that to be as easy as possible. So the Pandera programming model goes something like this. You define a goal, say I want to train a model, and then I go and look at my data. I profile it with various profiling tools. I explore the data, maybe in a Jupyter notebook. And then maybe in a separate script, I implement the data transforms needed to achieve my task. And then I also define schemas and tests concurrently. I then verify the data, and if the checks don't pass, then I have a misunderstanding of what valid data looks like. The transformation functions were not correct, perhaps. I didn't drop certain rows. And if they do, I continue the analysis. By the way, the code I'm going to show you here, this notebook, this presentation is an illustration of this, because in writing all the code for this notebook, I executed the Jupyter notebook that has Pandera code in it, so it is all validated by Pandera. So the programming model I like to boil down, and I kind of have to credit Eric Ma for this. I think he's the author for PyJanitor, which is also presented here. But he has this idea of data testing that's validating not only real data, but also the functions that produce the data. So again, data validation is this act of falsifying data against explicit assumptions. And as I just said, data testing is validating the real data and also the functions and the pipelines that produce that data. Oh, let me refresh this. So in the real world, you'll have some raw data. You have a schema in the green. You transform the function, and then you want to check whether that transformed data is correct. During development in your test suite, you actually want some kind of thing that generates data for you, because handwriting data frames, I can tell you from personal experience, very happy path biased. So you're just going to write one data frame, and you're not going to test all the different cases. Get into this a little later. But this is what testing the functions that produce the data looks like. So Pandera is an expressive and lightweight statistical typing tool for data frame-like containers. I'll show you a little bit of what that looks like. So there's the object-based API, which is the original flavor, and the class-based API, which looks a lot more like Pydantic and data classes. So here we're defining column names, the types those columns should adhere to, and various other properties greater than or equal to 0, the column is nullable, etc. This coerce flag is interesting because this actually tries to coerce the incoming raw data into the expected types. So when there's an error, so here I introduce some invalid data, Pandera will actually report the exact place where that error happened. So you see the failure cases, the index in which those occurred, and the check associated with that failure. Pandera supports transformations and inheritance. So with the object-based API, you can start off with a raw some kind of schema and then update the columns and the properties within it. And with the class-based API, you can inherit from upstream schemas so that you can kind of express the diff between the data. The way you integrate this into your pipelines is simply with type annotations and adding this check types decorator. So it's a few line code change to like actually get this into certain critical pieces of your pipeline. That test case generator that I was talking about, that's exactly what's happening here. I have my clean data schema. If I go back, that's over here. It has 2 columns. If I call .example, I'm going to get a data frame that's valid under the constraints of that schema. So I can integrate this with like PyTest and the hypothesis library to generate a bunch of data frames, and it'll kind of break a little bit that happy path bias. This was supposed to show the growth of Pandera. It's like a chart that goes like this, but apparently there's a rate limit here. So anyway, in terms of the evolution, though, after like this initial set of features, right, and some of the features that I showed you were part of this evolution. I just wanted to highlight a few of these major events, right? So there are massive documentation improvements, and I want to credit Nigel Markey for this. He was an early contributor to Pandera, as well as the PyOpenSci community. They really helped shape up the documentation, and that's half of a software, open source software project, right? There's like the functionality, and then it's like the guide to how to use these things. Class-based API, credit to Jeff Zank for this. This was a huge step change in the way, the conciseness of the API. Data synthesis, the synthesis strategies, this is something I implemented, a very grueling experience of like taking all the valid schemas that you could write and then using hypothesis to generate data against that. And another one from Jeff Zank, Pandera type system, which allows Pandera to express its own types, logical types, things like that. So you can say IP address is a string that follows this regex expression. So in terms of expanding scope as this project was evolving, there are more and more people requesting for various things. So one of parts of the Pandera story is scaling it. So what if you're using Dask or Modin or PySpark, right? So the path of least resistance was, okay, these are all not quite drop-in replacements, but the diff, like the number of code changes necessary were fairly small. So, Pandera supports Dask. It's the same exact schema, too. It supports Modin data frames, it supports PySpark.pandas data frames. And you can see these are all, they're all reporting all the same errors. So what about non-pandas compliant data frames? So there are a few design weaknesses that I detail in the paper and the proceedings you can read more about, but essentially there's a tight coupling of a lot of pandas assumptions with Pandera. For example, in the schema, there's just a lot of pandas code in there, and with the checks. And with error reporting, it assumed that you're working with in-memory data, and things were validated, run eagerly. So checks would run step by step in an eager fashion, as opposed to, say, in a lazy fashion. And there were a few leaky pandas abstractions like indexes, multi-indexes, and it's only really leaky with respect to these growing requirements, right? So they weren't really leaky originally, but when you have when you want to support polars, which doesn't have indexes, this is just an extra abstraction you don't have to reason about. But to its credit, there were a few strengths. So the schema interface was fairly generic enough, so there's a notion of columns and types. The check abstraction was also flexible, and similarly, the type system was also flexible enough to support new data frame libraries. So in the last part, I want to talk about the high-level approach for rewriting Pandera internals. The basic idea is that you want to decouple the schema specification from the validation backend. Very obvious thing to do, but when you're kind of first writing out these projects, it's like, you're just trying to scratch that itch as quickly as possible, so you're just writing code with the kind of the wrong abstractions in hindsight. There are a few more moving parts here, but I want to get to the end. So now the API for writing your own schema is that you write the schema for, say, this fictional sloth data frame. You write a backend for it and a few methods that these base schema backend exposes, and then you register that backend against that schema. So you can write your own backend, register that if you think you can, if you can implement a faster one or one that suits your needs. So the first case for this in the real world is the beta release for 0.16.0. Shout out to the Quantum Black team here for implementing all this. Pandera now supports PySpark SQL native data frames. So a lot of things to say here, but just wanted to make that quick announcement. And so to wrap up, I kind of wanted to share with you a few of the organizational and development challenges with this project where I'm essentially the sole maintainer and author. So during this rewrite, which took a few months, I had to multitask reviewing PRs and then retrofitting those changes into the new code, which I don't know if anyone has done that, but it's very, very, just breaks your brain. Also, the knowledge was centralized, so myself and maybe one other person knew the changes that needed to happen. So basically, I had to solo this rewrite. And because governance was informal, there wasn't really a mechanism by which I made basically a bunch of unilateral decisions to say, okay, these are the new abstractions. Obviously, it can evolve over time as well since it is internal code and doesn't break user space. In retrospect, there are a couple of things that were already in place to reduce the risk of regression. So there are like thousands of unit tests in Pandera, thanks to the hypothesis library. The pandas specific places in the code were localized so that it was fairly easy to find those spots. And with those early experiences adding Dask and Modin and PySpark pandas, we already identified the places that needed to change. Things I would do moving forward is more thoughtful design work, library independent things like error reporting, decoupling metadata from data, so like schema columns and their types versus the data values themselves, and investing in governance and community. So here are the updated principles, effectively just expanding the scope of the schemas being familiar to any Python user using any data frame library, and adding a new principle for making it as easy as possible to extend the interface. Quick announcement, Pandera has joined Union AI, which is the company I'm at right now. This means that it'll continue to being open source. I'll just have more resources to maintain it, and we can learn from enterprise users as well what their use cases are. Quick roadmap. If you're using a Polars and want to contribute to the Polars effort, come talk to me. There are a bunch of other things that I'm thinking about here in the next year or so. Here are a bunch of resources to join the community. You can reach out to me on Twitter and Discord, email, whichever you prefer. And just finally, quick plug, shameless plug, join me at the sprints later this weekend. We'll do a flight sprint. So not Pandera, but yeah, thank you so much for your attention.
Questions, anyone?
So I haven't used this before, but I'm intrigued, and I'm kind of curious about the performance implications of the validation, and specifically if this is something that you would have a production system have in place, or it's just during like testing and debugging you turn on validation, and whether that's configurable.
That is configurable, so in various ways. So the first thing I'll say about that is effectively the performance hit is effectively equivalent to if you were to handwrite assertions yourself for the data frames. There is a little bit of overhead on top of that because Pandera does various things under the hood for error reporting and things like that. There is a global flag now with the 0.16.0 to just disable all validation checks. And I do know there are several companies using this in production pipelines. So, you know, depending on the trade-off you want to make, you can use this at just like the very end of the pipeline, right? So you don't have to add schemas for everything. You like add the schema where it's most important. Especially for batch jobs, it's like the performance implications don't kind of wash away a little bit.
We have a question from Slack from Shubham Jha. How well does this play with Pandas 2.0, which involves PyArrow?
Sorry, what was the last part of that?
PyArrow?
PyArrow. So there's an issue out for supporting PyArrow types. But that said, it does support Pandas 2.0 plus today. It only supports the arrow types, a subset of them, and so we'll have to expand that. Yeah.
Any other questions for Niels?
Maybe I'm asking a little too much, but so most of the data sets I work with are fit more naturally into X-array data sets because they're multidimensional. I'm just wondering if there's been any thought on supporting that sort of thing.
Yeah, at this point, the extension story is very wide open. So with this internals rewrite that I talked about, effectively, you can write arbitrary logic and schemas for this. So as long as you have, it's not even really constrained by like mappings of keys to some array where there's like some kind of aligning factor, like an index or something like this. Short answer, would love to like work on that. I think there's an issue. If not, it's mentioned somewhere of someone wanting this for X-array and various other things. But yeah, would love to have support for that.
All right, one last question. All right, thank you. Let's thank our speaker one more time.
Thank you.